All right. Hi class, this is option 2 for the work time. This is the pre-recorded exploration. So this is for those of you who do not have access to any of the materials. You can watch me and my son do this experiment and fill out the worksheet together. But before we begin, I'm just going to show you the first video of us using the anemometer that we built based on the directions from the mini lesson. And so what you're going to do, hold the anemometer about 1 foot from the fan. You're going to see this in the video. It says you may need to adjust this distance depending on the strength of your fan. I started our fan on low. So we'll watch this video. And as you're watching, you have 2 questions to ponder. The first one is, why does the anemometer spin? The second question is, why does it spin in one direction and not the other way? Okay, so watch as it spins. It's only going to spin in one direction.
All right, so we have this set on low, and you're supposed to put on the stopwatch feature of an iPhone or any device, and you're just timing for 15 seconds how many revolutions. So how many, like every time it spins around once, that is 1. Okay, and I'm trying my best to count in the 15 seconds. Aiden's gonna hold it for us. Come on. Hold it about a foot away, so right there. Ready, set, go. 1, 2,
Can I hold
3,
myself?
4, 5, 6, 7, 8, 9, 10.
Okay, so really just wanted to show you about what a foot's distance is from that fan. You're not holding it right up on the fan if you do end up wanting to try this on your own. So think about those 2 questions. Why does the anemometer spin? Well, obviously it's because the air is filling up the cups and it is spinning in that direction. It's pushing it along. And then it says, why does it spin in one direction? Well, all of the cups are facing the same direction so that the momentum's all going in one direction. All right, so before we do any of the experiment part, we're going to make a hypothesis or, just some think aheads. This is a prediction. So it says, what do you think will happen to your anemometer's rotation speed when you increase the fan speed? So as the fan gets faster, as I move from low to medium to high, what do you think is going to happen to my anemometer's rotation speed? Go ahead and take a moment and make a prediction there about what you think will happen to the anemometer's rotation speed as the fan speed increases. All right. So now we're going to re-watch that video that I just recorded. And this is my son and I using the anemometer on low speed of the fan. So this is where you're going to start collecting data. And I only timed 15-second increments. And at the end of the video, we'll be able to fill in how many rotations happened on low speed. So here we go. I'll start this midway.
Set, go. 1, 2,
Can I hold
3,
myself?
4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
Okay. So in that time period, it slowed down a bit because my son was holding it at a strange place. But we're going to take that data. We're just going to use what we have. So in that time period, there were about 11 revolutions. So in your Make an Anemometer student worksheet, go ahead and write 11 next to low. Okay. To medium.
All right.
And in this one, I'm still timing for 15 seconds, but I have increased the speed. So let's see how many revolutions happen at medium speed in 15 seconds.
All right, so now we have it on a medium speed, and I'm going to record the revolutions in 15 seconds. It's easier if you just do a 15-second timer, so it just buzzes at you instead of having to multitask. 21. Okay, I got 22 that time.
Great. So almost doubled. Go ahead and write 22 next to medium in your data chart. Okay.
All right, so now
we're going to move to the high setting. So in the video, just watch as the anemometer picks up even more wind speed, and we should have more revolutions. So let's see.
All right, now I'm going to boost it up to the highest speed. Ooh, hurricane winds, tornado winds. 15 seconds. Let it start going and go. All right. 27 rotations on high.
All right, so I'm going to go ahead and type 27 next to high. So go ahead and write 27 on your Make an Anemometer student worksheet next to high in the data chart. Okay. All right, so if we look at all the data that we had, I'm just going to type this out to the side because I can't go back and forth. I know at low, I had 11 rotations. At medium, I had 22 rotations. And at high, I had 27 rotations. And this part of the worksheet is where you are graphing the data using a bar graph. And as you can see, this is going to be kind of tricky. We have to think here because there are not 27 spots going up this graph. There are only 1, 2, 3, 4, 5, 6, 7, 8, maybe 9, but 8, let's say, boxes. So we're going to have to break these into groups that make more sense. I would say let's maybe do by fives. So counting by fives. So I'm going to try to draw this on my chart. It might look crazy bad, who knows, but we'll say like this first line is like 5, this one is 10, this next one's 15, 20, 25, 30. Okay, horrible job with those zeros. Okay, and we don't need to go any further than that, but knowing that if I get to like this spot, this right here is going to be 30. That might be a great guide for us. So I think skip counting by 5. If you'd rather skip count by 10, you can. I just think this is going to help us get a better estimate of our drawing of the bars. So I'm going to go ahead and I'm going to show you low on here, and I'm going to let you fill in the rest on your own. So low, I got 11. If I were to finish this, I might use medium. I might use orange for medium, and then maybe I might use like green for high. Just color coded there, kind of like a key for my graph. That would be helpful to someone reading my graph. So I'm just going to plot my low, and then I'm going to let you plot medium and high. Okay. So since I got 11 rotations, I'm going to start here at low. I'm just going to go up to 10. And since it's 11, I might go a little past 10 just to show that it's a little bit more than 10. Okay, and if I really need my reader to understand, I can always, write inside of here 11. if I want, just so they know that like 11 is what I'm plotting. And then the same for 22. You're going to start at medium and go up to about where 22 would be on this number line, or not number line, this graph, I'm sorry. I'll be nice and do that one too. So I'm going to go up to 20. 22 is a little bit past. Then I would color that in. Again, I mean, it doesn't have to be perfect. But that's about 22. 22 is going to fall between 20 and 25, of course. And if I really want to help my reader or myself remember, I might would write 22 inside that bar. And then I'm going to let you guys plot 27 last on your chart. But this is showing you how you can use math and data and graphing to show the data you collected in science, so they're connected. All right, once you have drawn the high rotations bar on here, you have one question to answer at the bottom, and that's number 4. It says, what happened to your anemometer's rotation speed when you increase the fan speed? Did it go up, down, or stay the same? So really what this is asking, if you're confused by that, is as the speed went up, what happened to the rotations? What pattern do you notice? Like, is it increasing? Is it decreasing? Is it staying the same? Just like we've talked about with patterns in math. So do you see an increase, a decrease, or does it stay the same? Does this match your prediction? And remember, your prediction was your number 1 on this student handout, what you thought would happen if we increased the fan speed. Were you right? Were you wrong? It's okay if you were wrong. Tell me why. What did you learn by doing this experiment? All right, good luck and thank you.